All right, BNS 210, let's get back to factorial designs. Today we're going to talk about interactions, okay? And we're going to use this information to get us into ANOVA and thinking about ANOVA and talking about factorial designs. I do apologize, my throat is hurting. I think it's just strep throat. I went to the doctor yesterday, I'm taking antibiotics. We'll see. Okay, so she doesn't think it's a virus. So we'll see. Okay. So when we think about main effects, that's what we're going to talk about today. We're going to talk about main effects and interactions and what that means in a factorial design. This is only true. Main effects and interactions are only true for factorial designs when you have more than one independent variable. Okay, so we have talked about single factor designs. We are moving on past those. Okay. So what a main effect is it is the effect of one single independent variable. So if you have multiple independent variables, you could have multiple main effects. So here we have how many main effects in a 2x2? Well, how many independent variables do you have? You have 1, 2 independent variables. So you have 2 main effects possible. In a 3x2x2, you have 1, 2, 3 independent variables. So you have 3 main effects possible. In this one, you have 4 main effects. So if you are looking like if your independent variable is sex and you have your levels of male and female, those are your 2 levels, a main effect of sex would tell you that there was a difference between males and females. Okay, so main effect is a statistical difference that happens within a single independent variable. So whenever you have a main effect, that means that your independent variable is statistically significant. Okay. So let's go into this factorial design here. Actually, let me back up. Okay, so here's your factorial matrix. Do you remember when we had the factorial matrix? Okay, so this one we're going to think about our caffeine and reaction time example that we've been doing. So here we have a factorial design. This is a 4x2 design, and here we did our factorial matrix. So what we've done now is we are filling in these boxes with the means of each group. So here we have the males that got full caffeine. Here we have the males that got decaf, the males that got water. And this is their reaction time on average. Then we have the females that got full calf, half calf, so on and so forth. So this is what we have for each of these. Okay, so in order to do a main effect, okay, let's think about the main effect of sex. Okay. So here we have males, we have 25, 56, 34, and 20. These are the males, right? This is what we have up here in the top. So what we're gonna do is we're gonna add these up and we're gonna divide by 4. Okay, and we're gonna get the average for the males, which is 33.75. Then we're gonna go over here to the females and we're gonna do 18 plus 70 plus 35 plus 32. We're gonna add these up and divide by 4, and here is your mean for the females. So this is your main effect for females, for sex here. We have 33.75 for males and 38.75 for females. We would run statistical analysis on this and see if there's anything different between these, and that would tell us whether there was or was not a main effect of sex. We could do the same thing with our caffeine variable here, where we have full caffeine, half calf, decaf, and water. So water would be 20 plus 32 divided by 2. And so on and so forth. And so that these are the means for caffeine. This is regardless of sex, right? This doesn't matter. Sex doesn't matter for this. Just like the caffeine dose doesn't matter for this. This is just the reaction time for males versus the reaction time for females. This is just the reaction time of caffeine versus the reaction time for half calf versus the reaction time of decaf versus the reaction time of water. Let's do another example. We could do the same thing where we have, and we could see whether these 2 things interact with each other. So this is where we're going to get into interactions. So an interaction is so a main effect is just something that happens within one single independent variable, okay? An interaction is when one independent variable depends on the other. So it's changing because of the other one. So here we have our example. We've used this one before about the preference of THC versus age. So this is a 2x2 design. We've created our factorial matrix here. And what we have here is we have our means. So if we were to look at this, and we were to look at adolescents. So we would take 24 plus 6 divided by 2 is 15. Same thing here for adults. So what we see is that for age, like in general, the preference score is the same. So the preference score doesn't change whether they're adults or adolescents. Then we could look over here and we could say, okay, well, let's do this for THC and saline. You can see here that it doesn't matter, right? These are the same numbers, that we have the same preference score, so that THC and saline appear to be preferred the same. Just like adults and adolescents tend to have the same preference score. So there is no main effect of age, there is no main effect of THC, but what you can see is that adolescents do prefer THC compared to adults. And so this is where this is changing. The preference of THC depends on the age, just like age depends on the THC. So that is an interaction. Okay. Let me go through this example here. Just a second. Okay, so in this particular example, we have the effects of practice, a stress level on memory task performance. And so what we're going to do is we're going to have some people practice by reading a 30-word list. They're either going to read it once or they're going to read it 5 times. Okay, 2 levels. That's our first independent variable. And then we are going to tell some of the people that the number they get correct matters, and then that it doesn't matter, that most people can't remember them all, and then we're going to tell the next group that most people can memorize them all. So that's going to up the stress. So if you were supposed to memorize this and we're like, you know, most people remember them all. So that's a high stress group. So what we have here is we have this. This is the results. So we have in the low stress group, on average, when people read the list once, they were able to memorize a average of 8 words. If they read it 5 times, they were able to memorize 24. And then the high stress, if they read it once, they were able to recall 4 words. And if they read it 5 times, they were able to recall 6 words. So if you look at this, you can see that we do have a main effect of stress, which means that the low stress was able to memorize more words on average than the high stress group. Then we do have a main effect of practice, which means that people who practice more times were able to memorize more words. Now, we also have an interaction between low stress and high stress, in that if you are under low stress conditions and you're able to practice more times, this is the ideal situation, because this is whenever you memorize the most amount of words. So in this particular example, we have 2 main effects, a main effect of each independent variable, and we have an interaction. And to be fair, we would determine the statistic then. Okay, let's do one more. In this particular one, we have gone to a nursing home to discover caffeine's effect on the elderly, on their memory. And so what we've done here is we have our independent variable of time of day, where we test them in the morning or we test them in the afternoon. And then we have our independent variable of caffeine, where we either give them caffeine or we give them decaf coffee. Okay, so what this is telling us here is that when we test them in the morning, they got an average of 11.8 on the memory task, and in the afternoon, they got 11.7 on the memory task. Then when we test them in the decaf condition, they get 11 in the morning and 8.9 in the afternoon on the memory task. So they do better in the decaf in the morning than they do in the afternoon. So when we're looking at the main effects, it doesn't look like there's a main effect of caffeine, meaning that caffeine does not necessarily increase memory on our memory task. And it doesn't look like there is a main effect of time of day. It doesn't seem that morning is any better than afternoon. But what we do have here is we do have an interaction. And you can tell that here in this particular area. So what it means is that caffeine is helpful, particularly in the afternoon. That in the morning, the elderly are doing pretty well on their memory and they don't need caffeine, but in the afternoon, caffeine really does help with their memory. Okay, so this is what this would look like if we're graphing it. Okay, so when we have a simple 2x2 design, simple, this is our most simple factorial design is a 2x2. So we can have a main effect for our first independent variable, or we can have a main effect for our second. We can have a main effect for both, but no interaction. We can have a main effect for one or the other with an interaction. We could have a main effect with both and an interaction. We could have no main effects, but we could have an interaction. We could have no main effects and no interaction. So all of that is possible just with our simple 2x2 design. When we graph it, this is how you might be able to tell if you have main effects versus interactions. So here we're using the example of cocaine versus a D1 antagonist. So this is a 3x2 design. And I'm just going to show you here, we have a main effect of cocaine, but we do not have a main effect of D1, and we do not have an interaction. So you can see here, all of our lines are straight. They are parallel. They are not crossing. If we have a main effect of the D1 antagonist, but not a main effect of cocaine, we also have no interaction. All of our lines are parallel. They're all stacked in there, I promise. Okay, so here we also have a main effect for D1. We have a main effect for cocaine, but we do not have an interaction. Again, all of our lines are parallel. Okay, so this is what an interaction looks like. When we have an interaction of the variables, that is whenever you will see these lines crossing. So here we have an interaction. These lines are crossing when we graph it. If the lines cross, we have an interaction. If they're parallel, we have a main effect, probably. This one, the lines are not crossing, but because lines are continuous and are never ending, you could see that if this was to keep going, that it would eventually cross with this one and this one down here. So this one is also representing an interaction. And then this also is showing you an interaction because we have these two lines crossing here. Okay, so when you're graphing factorial designs, remember that your dependent variable is always on the y-axis, always, 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 and your independent variable is always on the x. Now, you can do this in multiple ways. You could have your either independent variable on the x, and the other one could be the legend, or vice versa. It doesn't really matter. So here's an example of how we have the variable of cocaine as the legend, and we have the independent variable of D1 on the X. And you can switch this up either way. Okay, so how do you know how many main effects and interactions are possible? Well, here we have a 2x2 design. In a 2x2 design, we have two main effects because we have two independent variables, and we have one interaction because these two independent variables can interact one time. In a 3x3, we also have two main effects because we have two independent variables and they can interact once together. In a 2x3, same thing. We have two main effects and one interaction. But if we add another variable, in this one, we have three main effects because we have three independent variables. But we actually have four interactions because this one, variable A, can interact with variable B, and it can also interact with variable C, okay? So variable A can interact with variable B, variable A can interact with variable C, variable B can interact with variable C, and all three of these can interact together. So we can have what's known as a three-way interaction with these. So this is there is four interactions possible here. Okay, so that's all for interactions. Feel free to ask questions, and thank you for watching this video. I hope you guys have a great rest of your day.